think it's a natural most people think it's a natural resource like Pacific Ocean and not something which is man-made. And these are not my words. Alan Key, the American computer scientist, said that in an interview in 2012, but they hold very true in regards of how the system should be built. Hello, everyone. This is Vikas, and I'm going to talk about design for failure. It's a fairly small 15-minute talk, so I'm not going to talk a lot about the implementation details, but more around the principle we adhere to build these resilient systems within Chegg. So let's start the journey, and I'll start it with the story of Param Sharma. Who this guy is? Param Sharma was on May 10th was held by CHP, which is California Highway Patrol, on the Bay Area roads, and was put behind the bars. His crime was that he was sitting on the back seat of his car. Well, you will say what kind of crime it is. The problem was that there was no one sitting on the front seat of the car. It was a Tesla which was driving on the road by itself. He was caught for negligence driving and whatnot. After 40 hours, when he came back from behind the bars, he went and bought another car because his previous car was impounded. And he again did the same thing. When he was asked why he's doing it, he said that, I trust this car and I want to prove a point that everything worked well. Despite being so many moving parts like cameras, radars, GPS, and so many systems, this guy trusts the car more than his own driving capabilities, probably even more than what Elon Musk believe in Tesla. Why this story is relevant to us, because we as a software engineer interact with so many external systems when we design our services, design our systems, external libraries, services, cloud infrastructure. Most of the times in past, it used to be more in-house infrastructure, databases, even networks, which we can say that, reliably the most unreliable thing. We trust that everything will work with our services. We always focus on what we are building and just keep our focus pretty narrow to that particular piece rather than thinking how it will interact with overall ecosystem with which we are building it. And as Murphy's Law said, that anything that can go wrong will go wrong. So the takeaway from that is trust not to trust anything, and build resiliency in design. But why we want to build resiliency by design? Because there is a cost associated for downtime of your services. It's not just a monetary cost, it's the trust of your clients in your organization, in your management trust in your team, and your team trust probably within you. The reliability of your software systems, the reliability of your company, everything is at stake. So we should always think designing resiliency within the design rather than thinking after the fact thought. And we all know that eliminating all failures are not possible in software systems. So what should be our action plan? Action plan should be to define your strategies and design for failures. As I said earlier in the start that I'm going to talk about the principle we adhere to, that's I'm jumping into now. I'm going to talk about almost 5 of the principles. They are not the only one. There are a lot many, and few of those depends on what kind of systems you are building. You're building a simple web services, or you are building something more sophisticated, like aeronautical system where failure could become a disaster. So those things probably can vary, but these 5 principles which I'm talking about today going to be used in every aspect of software life, no matter what kind of system you are building. So let's jump into those. Decide what success and failure will look like. When you start on a project within a team, you could have different understanding of within the team itself, like what success and failure look like. We were building this Chegg assessment and proficiency platform. And we went to our product team and we asked them, hey, in case of things goes wrong, what do you think we should, show to the user? And they are like, well, there is this, standard error page in Chegg. If something goes wrong, we show it. And we are like, is it, or do you want us to do something better? They are like, what do you mean by better? So we told them that the way we see the product is, there's this content which we give to the user, and that's the primary portion of it. All these questions, answers, study contents. But the second thing is the experience. We also give them the experience to to see that content. So we say that worst case, if we can't serve the content, but we still capable of serving the experience, if our web tier is working, is that okay? And they were kind of really happy about it. So if you'll see this screen in the top orange bar, you can see that we are showing it in the outage mode. This is a practice page of our services, and we have all these courses available on this, but not right now. It is in you are viewing it in the outage mode, and the only course available right now is Introduction to Statistics. The idea here is that as a biology student or a chemistry student, probably statistics will not make any sense to you, but the experience will make a sense. You know, next time when you'll come and the system will not be in outage mode, how you can interact with, how you can see a question, how you can interact with the question, what all components of the questions are available. You can see the solution, you can go step by step, you can answer all those questions. So it's primarily working out with your teams, all the stakeholders, and basically defining your definitions of success and failures. It's not always black and white, 1 or 0. These two son of a buffalo are Hira and Bhola. My grandfather used to recite this story to me, and I'm using it for my second principle, which is fail fast. One morning when they wake up, Bhola was not feeling well. He don't want to go to the field and do anything, but Hira was so energetic and looking forward to go to the field. So Bhola doesn't want to disappoint his friend, and he decided that okay, I'll go and do it. They start working in the field, but within 10 minutes, since it was very intensive work, Bhola gave up. He fall down, and when he fall down, the owner lost the control of the plow, and the sharp blade went through the stomach of Hira. It was a disaster, sad story. Not going to cover the complete thing here, but for my principle, the takeaway is that we have so many Hiras and Bholas running in productions, all our services, which are calling each other, which are helping each other. But the problem is, I think all our services, as owner of our services, we decide to behave as Hiras and Bholas. Whenever our services are bombarded with the request, we probably don't do due diligence to basically say that, hey, we can't serve you at this point of time. So I think it's important to fail fast. Have Bhola told Hira earlier that he's not feeling well, it probably could have been recovered within a day, while as now the disaster is way more. So use the techniques, like if you are a client which is calling any producer, so have your dependencies time out very aggressive so that you don't bombard the system again and again. Use the patterns like circuit breaker. Or if you are serving and not capable of because you don't have enough resources, just do a client back off. Use techniques like 429 too many requests, or there's a lot many techniques, but the whole idea is to fail fast. Our third principle is limit the uncertainties. When we build things which we are already aware of about, I think it's easy. But when we start building newer systems, there's a lot of uncertainties. We don't know about them. There's no story associated here, but if these guys will jump and they don't know how much deep the water is, they probably hit the ground way faster and can't swim. Try to limit your uncertainties when you build new systems. Write down what are your unknowns, what are your knowns, and try to keep your focus as narrow as possible to keep your uncertainties within the limit, especially the system you are not aware. Like we every day build these web applications, but if you start building these asynchronous applications using all these Kafka queues and whatnot, or maybe I'm just giving an example, you're probably not aware about that technology. So try to reach out to someone within your organization or try to learn from across the industry how they are implementing and doing those things. Do your POCs, start with that narrow approach. Next one is convert your assumption into knowledge. So every time we start a new system, we create certain assumptions, and most of the times those assumptions basically fail. So it is important to explicitly write your assumptions, share with your team, and basically work around those assumptions. I'll take a story here. Chegg Study is one of our best-selling platform where it's, traffic patterns and everything is humongous within Chegg. And as I told, we were building this assessment and proficiency platform. It is pretty good and popular system right now, but not as popular as Chegg Study. So we decide that we'll integrate both the platforms so that user can get benefited by having practice and everything. Both the systems were working really great in their silos, and we just integrate and make sure that all the flows and everything working fine. On the day of release, when the Chegg Study traffic bombard this new system, everything fails. Well, this is a hypothetical story. Nothing like that happened because we were aware about all the patterns. We were aware about all the data of Chegg Study, how many users they have coming per minute, and how many servers they are running on, what kind of infrastructure they have, their auto scaling policies, all the data which these applications were generating. We look closely at that information and create a knowledge and make sure that this newer platform basically capable of serving all that traffic which is coming to Chegg Study. So we didn't assume, we basically use that data, that information, convert our assumption to the knowledge, and then that's how the overall flow works pretty well. And the last one is basically codify and share what you learn. So whenever an incident happens within Chegg, we basically document that incident, and it doesn't just stay with the team or with the area where it happens. We circulate it so that other teams, other peoples, and all the engineers go through it and basically look at the root cause, what was happening there, and make sure that all those root cause kind of situations are not there within their own systems, within their own service, or within the domain that they are working on. So it is important to basically share the knowledge, the best and worst best practices and worst times in terms of incident. Whatever we have, we basically share across the organization and make sure that all those knowledges and things are implemented across all the services. So with that, I would like to summarize. Here are your principles. Look at your principles, your success and failures. Your FMA should be ready upfront, even before you basically design the systems. Acceptable outcome for all the failures. We fail fast, use all this circuit breaker, back pressure, and these kind of techniques. Limit your uncertainties, do the POCs, whatnot. When you start working on such a system, reach out to people. Convert assumption into knowledge, safeguard against successes, and software defects, human errors, anything can happen. So have a strategy for everything. Codify and share what you learn. Have your run books ready, incident reports and retros, document things, create videos, educate. With that, I'm open for questions.
Hey, that was great, because one question to you is, how do you see the adoption of all these principles at Chegg?
Yeah, so I think in industry, I think all of us are aware about these things, but it's more about practicing them. Knowing is one thing, but making it a habit is another thing. So whenever we basically start building things, we have these step-by-step things where we have within the team, like when we start designing, we have within the team review, and then across the org review, and finally we basically reach out to the architectural group and they also review, and they ask all these questions because they deal with so many systems every day. So we want to make sure before going to them that all these things are taken care within the design when we talk about our design and architecture, even before we start building these applications. So that's how we adhere to these principles.